I want to move on now to another way we can use trig functions to solve integrals. So let me start out with a special graph. This is the graph for the upper half of a circle. And you probably know this formula already, right? So let's say this is a circle with radius 1. That means that y is going to be what? It's the square root of 1 minus x squared. You've probably seen this in a previous class. So, it stands to reason that if I integrate this formula, square root of 1 minus x squared dx, and I go from minus 1 to positive 1, now this is a definite integral, so I am calculating the area between this curve and the x-axis. I know that this area is going to be 1/2 of the area of a circle of radius 1. So I should get pi times 1 squared divided by 2, or pi divided by 2. I highly recommend using this area idea whenever you can. It saves a lot of work. But how would I try to solve a problem like this? How would I try to integrate square root of 1 minus x squared, right? If this was just an indefinite integral. I can't use a u substitution, at least not the usual way. Because if I try to say the most nested part of this function is the 1 minus x squared, the derivative of that is the 2 times x, and I don't have a 2 times x to play with. So now that we're remembering u substitutions, and we're a bit more comfortable with those, we're going to use them in a bit of a different way to work on integrals like this. So, rather than saying u equals 1 minus x squared, right? I already said that's not going to work. I'm going to do a change of variables a different way. I'm going to say that x itself is something else. That perhaps this x is the result of someone else's u substitution that made the integral harder instead of easier. Now, this might not be an obvious choice, but I'm going to pick x equals the sine of variable theta. So this is what I would call a trig substitution. The idea is that we're going to